So in this video, we are going to solve problems from exercise 8.2, which belong to chapter number 8, quadrilaterals. So let's see what is problem number 1. So let's come down. Okay. So ABCD is a quadrilateral in which PQRS are the midpoints of the sides AB, BC, CD and DA. Okay. So let's try to understand the figure. So we have this ABCD as a quadrilateral, and it's a random quadrilateral, not a very specific quadrilateral. And we have this PQRS, which are midpoints of the respective sides. Okay. Quite simple and straightforward. Now, AC is a diagonal. Okay. So this AC, yes. So this AC, as you can see, is a diagonal. We all know what is diagonal. Diagonal is a line which connects the opposite vertices of a quadrilateral. So AC is one diagonal in the quadrilateral. Show that, okay, show that we have to show one, two, three things in this diagram. So the first thing, let's focus on first thing. We have to show that SR is parallel to AC. So this line SR is parallel to AC and SR is half of AC. SR is half of AC. So let's focus on this first thing. So first of all, let's get rid of this highlighted things. Okay. So let's come here and try to zoom in into this diagram. So as we can clearly see, let's highlight this triangle. So if you look at this triangle DAC, okay, in triangle DAC, we know that S and R are the midpoints of the two sides. So by straightforward application of midpoint theorem in a triangle, SR, okay, will be parallel to the third side AC and SR will be half of AC. Okay, so I'm just going to write down this in triangle DAC. Okay, SR is equal to half of AC and SR will be parallel to AC. From where does this come? This basically comes from, okay, midpoint theorem. Midpoint theorem of a triangle. Okay, midpoint theorem of triangle. So it's a very simple and straightforward application of midpoint theorem of a triangle. Similarly, let me try to zoom out. Okay, very similarly, now second point, and before that, let me just erase this. The exact thing applies to the other half of the triangle, which is the triangle ABC. Okay, look at this triangle ABC. In this triangle ABC, again P and Q are the midpoints of the two sides AB and BC. Okay, so P and Q are the midpoints of these two sides, which means the line joining the midpoints PQ will be parallel to the third side AC and PQ will be half of AC. Once again, this is a straightforward application of midpoint theorem of a triangle. So I'm just going to note that down. In triangle ABC, so this was our triangle ABC. Once again, we have PQ as equal to half of AC and PQ will be parallel to AC. Okay, why is this so? Once again, the reason is the same, midpoint theorem of a triangle. Now, if okay, so let's come back to this proof. What are the things we want to prove? So the first thing is done, I guess. Okay, we have proved SR is parallel to AC and we have proved SR is equal to half of AC. Now, the second thing we want to prove is PQ is equal to SR. Okay, so this PQ is equal to SR. So again, that's very obvious. If you let me use a highlighter, look at this. SR is half of AC. Okay, and PQ is also half of AC. Okay, so very clearly, so I'm just going to write here. Thus, okay, let me try to zoom. Okay, so point number three. Point number three. Thus, okay, SR is equal to PQ, which is equal to half of AC. Okay, so in short, SR is equal to PQ, and that is what is the second thing that we have to prove in this question. So let me put the tick mark. Yes, second thing is also done. Now, the third thing we want to prove is PQRS is a parallelogram. Okay, so let's come to this figure once again and let's try to erase this. Okay, so we want to prove that this is highlighted. Yeah, so we want to prove that PQ, R and S, this thing is a parallelogram. Now, what is the characteristic of parallelogram? The basic definition of parallelogram is a quadrilateral where the opposite sides are parallel to each other. So we have just now proved that PQ is parallel to AC Okay, let's come here. PQ is parallel to AC and SR is parallel to AC. So what I will do is I'll get rid of this highlighted things. Okay, so let's get rid of this highlighted things. Now focus on this highlighted part, that SR is parallel to AC, okay, and PQ is also parallel to AC. So we know that if two lines are parallel to the same line, then those two lines are also parallel to each other. So once again, now okay, so I'm just going to write here point number 4. Also, okay, also SR is parallel to PQ, which is also parallel to AC. Okay, all these three lines are parallel to each other. So what we need is this thing, SR is parallel to PQ. Okay, so if you look at this quadrilateral now, sorry, if you look at this quadrilateral, we have the opposite sides SR and PQ parallel to each other and equal to each other. Okay, these two things, SR is equal to PQ and SR is also parallel to PQ. So if the opposite sides of a quadrilateral are parallel to each other and adjust and equal to each other, then the given quadrilateral is a parallelogram. That's a theorem. So PQRS will be a parallelogram. Okay, so by that we also complete our third point. So thus we have proved all these three things which were asked to be shown in this given figure.